Arithmetic progressions are series or sequences, whichever we'd like to call them, that increase or decrease by the same number. So what we have here is a series. Here's an example: 10, 13, 16, 19. The first term is called A, and that's 10. So that's the first term in the series. Then it goes up by 3, then it goes up by 3 again, goes up by 3 again. That's what we call a common difference. And we give that the pronumeral D. So in this series we call A10 and D3. So A is the first term, D is the common difference. Every arithmetic series has a first term and a common difference. Now, to find any term in a series, we're going to use a formula. Now, we can start adding numbers and get terms in a series, but if we want to find something like the 100th term in a series, that's going to take a lot of calculation to get there. What we want is a simple way to do that. Now, the formula we use is A plus n minus 1 times D. Now, A and D are from before. A is the first term, D is the common difference. N is the number of terms in the series. So if we want the 100th term in the series, n would be 100. If we want the 10,000th term in the series, n would be 10,000. And we use the notation Tn. So T and then whatever term in the series we want. And that would tell us that we're finding a term in the series. But this is the formula you've got to remember. So let's apply that formula in some of these examples. So if we want to find the 16th term in the series, what we've got to identify is A, D and N. So the first term is 6, so A would be 6. The common difference, we go from 6 to 10 to 14, so 10 minus 6 is 4, 14 minus 10 is 4, so D is 4. And we're told we want the 16th term in the series, so N is 16. So that leaves us with T16 is equal to A plus N minus 1 times the common difference. Do the calculation, gives us 66. In our second question, what we want to do again is find A, D and N, because we want to find the 15th term, so N is 15. The series is 8, 13, 18. So A is 8, first term's 8, and then we go up by 5, and then we go up by 5 again, so D is 5. Substitute that into the equation. 8 plus n minus 1 times the D, which is 5, gives us 78. The next question, here's the 100th term in the series. So you wouldn't want to add these all together and keep trying to find different terms. So again, n is 100, D is 6 because we go from minus 4 to 2, 2 to 8. So we can do the subtraction of the third term minus the second term minus the first, and that will give us 6 every time. The first term is minus 4. So the 100th term in the series, A is minus 4, n minus 1, 100 minus 1 times D, and the calculation will give us 590. That would be the 100th term in that series, which seems reasonable because it's going to get large. This time we have to look at our one for the 65th term in the series. So n is 65, and we're going to have A as being 62. That's our first term. But if we notice this time our series is getting smaller. So we're actually going to go down by 2. 60 minus 62 is actually going to give us minus 2. 58 minus 60 gives us minus 2. It's going down by 2. Apply it to the formula again. Tn, A plus m minus 1 times D. Do the calculation. It gives us minus 66. This one's a little bit different. This time we want to find out what the value of n is. So we know that the nth term is 320, but what is that value of n? Again, look at our series. Our first term is 2. Our common difference is 3. So we've got 3 out of the 4 parts. This time we've got Tn, but we want to find n. We've got A, we've got D. We do the substitution, and then it's just about the algebra. Expand the brackets, collect the terms, solve it to get n is equal to 107. Be careful. If you don't get a whole number there, you know you've done something wrong. N has to be a whole number. It can't be a fraction, can't be a decimal, because n has to be a term in a series. If it's not a whole number, it's not a part of the series. Looking at how many terms there are in this series again we want to find what n is. We identified that Tn is 157, A is 3, it goes up by 7. So our common difference is 7. It's just another way of writing that previous question. So we express our equation this way. Get down to value for n of 23 by solving the algebraic equation there. N is equal to 23. Again, can't be a fraction. That one looks pretty good. This time question 7, is 102 a term in the series? With the nth term 3n plus 1. So if 102 is going to be a term in the series, we should be able to find a value for n that should be a whole number. That's the key. We say that 102 would be equal to 3n plus 1, but in this case 3n will equal 101, or n is equal to 33 and 2/3. Again, n has to be a whole number. It's 102 can't be a term because n comes out as 33 and 2/3. There's the test for an AP. We've done that a number of times in this question. We just take the common difference, and it has to be the second term minus the first, and then the third minus the second, the fourth minus the third, and so on, would always equal the same number. So keep that in mind when you're looking for that.